All right, ladies and gentlemen, what we're going to talk about right now is transforming and combining random variables. Okay, so example 4, we have El Dorado Community College. Yes, that is a real community college. I believe it is in Arizona. My students in the past have always Googled it. So it is a real community college. El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. So units is like a credit. The number of units, capital letter X, that a randomly selected El Dorado Community College full-time student is taking in the fall semester has the following distribution. Find the mean and standard deviation of the distribution. So this is the expected value and the standard deviation. I want you to pause the video right now. I want you to do that on your own. I have it done. I'm not going to re-go through how to do that because I've already done a couple videos on that now. Okay, hopefully you practiced it on your own and here's what you had. So our expected value, remember we're taking each observation, multiplying it by the probability and adding it up. Please note here when I showed my work, which you are required to do, I took the first observation, the second observation, and then because there was a lot of them, or there's more than like 4, I did this ... thing. That is okay to do. And then just finish off on the last observation with that probability of that observation. So I got 14.65 there. Then the standard deviation, remember we take that observation minus the mean, the expected value. We square it and then we multiply it by the probability of that observation. We do it again, minus the mean squared times the probability of this observation. So 0.1 plus ... I didn't even finish with the last one. I don't know why I have this line over it, but that is equal to 2.057. Please make sure you know how to interpret the mean and that standard deviation as well. That was in the first video that you watched, but that's very important. Okay, so we have this here. So this is going to kind of set the stage, this community college here. Now, at El Dorado Community College, the tuition for a full-time student is $50 per unit. That is, if T equals the tuition charge for a randomly selected student, it is going to be T is equal to 50 times the number of units. Okay. Write a new probability distribution for the El Dorado and then find the mean and standard deviation. Oh gosh, spoiler alert here. Okay, so again, it's $50 per unit. So if I have T is equal to the tuition and then the probability of spending that amount of money. Well, if I'm taking 12 credits here, 12 times 50 is going to be $600 because it's $50 per unit. It's still a 25% chance that that could happen because there's a 25% chance that people, if they randomly selected, you have everyone from El Dorado Community College's name in a hat, you pull out one name, there's a 25% chance that that person's taking 12 units. That means they're spending $600. Okay, so now let's go to the next one for that probability distribution. 13 times 50, okay, well that's 650. There's a 10% chance if I pulled someone's name out of a hat that they're going to be taking 13 units. That means they're paying $650. That's 0.1. I could continue to do this, ladies and gentlemen. I could continue to do this. Or back from unit 1 and unit 2, we learned about transforming data. Okay, we learned about that and what happens to their statistics. And a mean and a standard deviation is a statistic. And right now what's happening, ladies and gentlemen, is we're multiplying each value here by 50. The probabilities stay the same, but what do you think is going to happen to that mean when we multiply it by 50? If I just take this mean, if on average, we know an El Dorado Community College student takes 14.65 credits, we can just multiply that by 50 to find the average tuition. So the expected tuition is just 50 times the expected number of units. 50 times 0.1465 is equal to $732.50. See, a long time ago at the beginning of the unit, we learned when we're transforming variables or data, the mean is affected by multiplication and addition. But the standard deviation is only affected by multiplication. So again, what would happen to this standard deviation, 2.057? All of these values here are being multiplied by 50. The standard deviation will also be multiplied by 50. So there's no need for us. They just wanted us to do this as an investigation. And I'm just trying to do you a favor to talk about, hey, do you remember what we've learned about when we transform data? We can just take that 50 and multiply it by the expected value. We can take this 50 and multiply it by the standard deviation, which will give us a standard deviation of $102.85. All right, let's move on to the next slide. In addition to tuition charges, each full-time student at El Dorado Community College is assessed student fees of $100 per semester. If C equals the overall cost for a randomly selected full-time student, C is equal to 100T. So what I did is I rewrote it down here as thinking about the number of units. The total cost that someone's going to pay is they're going to pay $50 times however many credits they've taken, and then they have to add $100 to it. Guys, we don't need to redo a whole probability distribution. We don't need to take each value and multiply it by 50 and then add 100 to it. Because we know when we're transforming data, the mean is affected by multiplication and addition, but the standard deviation is only affected by multiplication. Remember, a long time ago, we looked at test scores from 5 to 10. What would happen if we added 10 to each of them? The spread doesn't change. But if we had test scores from 5 to 10, and we multiplied everything by 2, now everything changed. Okay, so moving on, right? Let's do that then. We know we took that original distribution, we multiplied it by 50 and then added 100. So in order to find the expected value for the total cost, we're going to take the expected number of credits, the average number of credits. We're going to multiply it by 50 and add 100 because the mean is affected by multiplication and addition. When we do that, we get $832.50. But now remember, for that standard deviation, that's not affected by adding or subtracting to it. That's not affected. So the standard deviation, we're only going to multiply the standard deviation of the number of credits times 50. It is not affected by that addition of 100. Okay, that's why we only take the standard deviation of X, the number of credits, and multiply it by 50 to get $102.85. Okay, so let's just kind of summarize here. When we have this probability distribution, if we would have graphed the probability distribution each time, we could have done that. We did that in our first video. The probability distribution of Y has the same shape, okay? So the shapes are not going to change as the probability distribution of X if it's going through a transformation. So you can see we have this transformation here. You could think of it as like the soccer goals, right? And we want to transform it to something new, like whatever, or grades on a test or whatever you can think of, right? We want to transform it by multiplying it by B and then adding A. When we do that, the shape is not going to change. If it's symmetric, it's going to stay symmetric. If it's skewed right, it's going to stay skewed right. Skewed left, it's going to stay skewed left. Now the mean of Y, so the new Y under the transformation, that's going to go through everything. A plus B times the mean of X. But the standard deviation of Y, that is only affected by the multiplication. So we say B times the standard deviation of Y. Okay, so this was the video about transformations. The next video is going to be about combining distributions together.